Hello, geometry friends. How are you? I hope you're having a good day. I need a tagline like, hello, all you cool cats and kittens, but that just doesn't seem, I don't know. I need something. If you have ideas, let me know. All right, we are going to talk about the surface area and volume of a cylinder. And so this is our next solid for the solids unit. Okay, so we're going to take a look at the net of a cylinder because that's going to help us understand the formula. So remember that if you unravel like a soup can, if you take the label off of a soup can, it's rectangular, right? And it's just wrapped around the can. And then you have, if you could peel up the top, you'd have a circle, and if you could peel off the bottom, you would have another circle. So we have two circular bases in a cylinder, okay? And the shape of the lateral net, so that's right here, is a rectangle, and that's always going to be the case for a cylinder. So that net is going to help us to come up with the formula for a cylinder. And really a cylinder is just a prism because it has two bases with, with two circular bases. So it's a prism with circular bases. So let's go back up and I'm going to redraw that net another time. And because of the circles, we can get some really specific formulas. We don't have to be generic with the total surface area being 2b plus p times h. Okay, and remember b is the area of the base. Because we know that our bases are circular, right? 1, 2 circular bases, and the area of a circle is pi r squared, we can substitute that in for the area of a base. So we've got pi r squared, that's the area of one base, times 2 gives us both bases. Plus, and then we can change this p times h to be more specific as well. Because remember, p was the perimeter of the base. Well, if our base is a circle, the perimeter around a circle is called the circumference. So that would be 2 pi r or pi times d. So we're going to exchange p with a more specific formula of 2 pi r times h. And there's our total surface area for a cylinder. 2 pi r squared plus 2 pi r h. Okay? If we want just the lateral area, we need to take those bases away. So that would be 2 pi r h. And if we want the volume, we need to take the area of the base, so that's pi r squared, times the height of our solid. I should label this. This is height, right? This is the area of the base, this is area of the base, and then this length right here is the perimeter, but that's also known as circumference, which is 2 pi r of that base. So the volume is going to be the area of your base, pi r squared, just one circle, times the height of your solid. All right, so those are our three formulas that we need for cylinder. Okay, so we can put those on your formula sheet. So here we are, cylinder. Remember, for prism, this was 2b plus perimeter times height. This was area of the base times height. That's equal to surface area. That was a little, and then I think I underlined this maybe in red. I don't remember, for lateral area. So for a cylinder, the total surface area is 2 pi r squared plus 2 pi r h. And again, that lateral area is just the 2 pi r h. And the volume is pi r squared times height. Okay, so you might want to pause if you need to catch up on that, or you can rewind back to that part. All right, let's take a look at a couple examples. So find the lateral area, the surface area, and the volume. So the lateral area for a cylinder is 2 pi RH. The total surface area is 2 pi r squared plus 2 pi RH, and the volume is pi r squared times h. And we're going to leave this in terms of pi. And I forgot to grab my calculator, so hopefully the numbers are friendly. Okay, so let's identify our variables for this particular cylinder. So there's only really two variables we're looking at. We are looking at, well, that didn't work. We are looking at the radius, right? And the radius here is 3 feet. And we need to know the height of the solid, and the height here is 6 feet. And those are the only two variables we use, okay? So if our radius is equal to 3 feet, and the height of our solid is equal to 6 feet, we can find the lateral area is 2 times pi times the radius times the height. So 2 times 3 is 6, and 6 times 6 is 36, and 36 times pi is 36 pi, we're leaving it in terms of pi, square feet. So that is that lateral area. Okay, so that area if we unravel the soup can. The total surface area is, let's see here, I'm going to run out of room, but that's okay. 2 times pi times the radius squared plus that lateral area, which we already figured out was 36 pi. So we can just pop that in there. 3 times 2 is 9. 9 times 2 is 18 pi. Excuse me. And 18 pi plus 36 pi's, well, 36 plus 20 would be 56 minus 2 is 54 pi's. And that's also in square feet. And then finally for our volume, we've got pi times the radius squared times the height. So now we've got 3 squared is 9, and 9 times 6 is 54, and 54 times pi is 54 pi. But now we're talking about cubic feet, so 54 cubic feet. Okay, so again, it can happen where you have the surface area and the volume equal, assuming I didn't make a mistake, which we know is quite possible. So, okay, so that's an example. This next example is very similar, except it's a cylinder on its side. Just because it's on its side, the base is still a circle. The base is defined as being the two parallel parts, okay? So it's like a can of tuna on its side, right? Okay. And then also the other thing to be careful of is that make sure that you are not given diameters, or if you are, that you just cut them in half for your radius. All right, let's use these three formulas and move right on through this one. The lateral area is equal to 2 times pi times the radius times the height. And the height and the base have to be perpendicular. So this height intersects that base at a 90-degree angle. Okay. So right there is a 90-degree angle. And that's, even though it's on its side, that's still the height. All right, 9 times 8 is 72, and 2 times that is 144 pi square feet. For our total surface area, we've got 2 pi times our radius, 9 squared, plus that lateral area, which we already figured out was 144 pi. So again, 9 squared is, that's 81. And 81 times 2 is 162 pi. Plus 144 pi's is what was that, 306? So let's see here. Let's do it old school. 6. Yep, 306. So 306 pi square feet. And then finally for our volume, we've got pi times the radius squared times 8. Okay, here we go. So 9 squared is 81. So we've got 81 pi times 8. So 81 times 10 is 810. And then we need to take away 2 81s. So take away 162. This is what I get for not grabbing my calculator. So we get an 8, and we had to borrow. And let's see here. So we need to borrow again. We've got, so 9 times 6. Oh my gosh, I've made a mess of this. So 3, and then we've got 7 times 6 is 638. If that's not 638, well, just forgive me, and you can leave a comment about what it really is. And that's cubic feet. Eight times 80 would be 640 plus one more 8. So I think it's 648. Oh my, I don't know. See, I need to go back to 5th grade or go teach some 5th grade math. Anyway, whatever that answer is, 638, 648, that's what I get for doing this on a Sunday night. That is it. That is how you find the lateral area, surface area, and volume of a cylinder. The key is that the circles are always the base. The cylinder can be sitting on its side, so don't mix up the height and the radius, but otherwise that's pretty straightforward. So that's it. We will dig into pyramids. So they're kind of like prisms, but they come to a point. And we will start that tomorrow. So I hope you have a great day. Happy Monday. And we'll talk to you later. Bye.